И май сме готови да започваме. Здравейте на всички, добре дошли на нашия октомврийски Meetup. Преди да започна, всички ли говорим английски? Or anyone needs to... Everyone? Anyone? No? You? Okay. Така че продължавам на български. Добре, здравейте, добре дошли. Очевидно сме в Acronis, много благодарим на Acronis, сега ще кажа защо. Пак прословутия сайт, който за този Meetup. Това сме ние тримата, аз съм Орлин, Спаса е там снима, Владо някъде работи. Благодарим на Acronis за пореден път, че ни приемат да ни хостнат днес. Малко логистика. Тоалетната е в този коридор и веднага в дясно. Вода има е там, бирата ще е накрая. Така че съжалявам. Днес какво ще си говорим? Днес имаме двама спикери. Антон е DevOps в Acronis и ще ни говори за Load Balancer. И имаме Борислава от VMware by Broadcom by VMware, I don't know. Тя ще ни говори за KCP и за проекта, който случайно използват в Tanzu, но тя ще ни разкаже. Но днешния Meetup, освен темите, е супер специален, защото го правим съвместно с Social Community. Woman Who Grow, преди се казах Who Code, за който знае. Това са данните, които са зад тази фундация и комюнити. И после Рени ще излезне да ни разкаже малко за фундацията и за те всъщност какво правят. Нашата идея да ги поканим на нашия Meetup е всъщност да съберем тези две общности, да си колаборираме, казвам чист български, и да правим някакви неща като Meetup-ите заедно. Следващото нещо е, следващия ни Meetup ще е SiteGround на 21-ви. Следете, ще отворим събитието, може би тази седмица. Така че ще видите аджендата за тогава. Надявам се този път аджендата да мога да я публикуваме на време, т.е. като отворим събитието. Следващата тема е KubeCon. Някой ще ходи ли на KubeCon? Всеки път си дигнам само с ръка, мамко. Добре, ще ходим на KubeCon. Ако някой път все пак реши за виртуалната част да се регистрира, то код също важи. Последно, почти. Как да се свържете с нас, ако искате да говорите. Мисля, това всеки път го обсъждаме. Следващите слайд е един QR код, но има много тук, малко не го обсъждаме всеки път, ама трябва. Cloud Native Community Groups. Някой регистрира ли се там? Има някакви хора, примерно 50 човека. Meetup групата ни е 1900. Само така ще кажа. Там имаме 50. За продължаваме съществуваме като официален CNCF Meetup. Малко ще трябва и там се регистрирате, така че моля да го направите. Не, че е проблем, но водени безкрайни с тях разговори, че трябва да го направим и там, и да ръбъра. Но така. Slack, Facebook, за тези, които имат Facebook. И сега, последно, обещавам, be a speaker. Пак ще апелирам, използвайте ни като платформа да тренирате вашите presentation skills, пак на чист български език. Съмитнете, имаме една форма, като го сканирате това нещо, или пък пишете на мене, на Спас, няма значение. Ще изпратим едно линкче, да го попълните, там събираме бъдещите теми, обсъждаме ги с хората, които искат да говорят и свързваме обратно с вас и намираме подходяща дата, подходящ ивент. Още едно нещо. Билдваме, правим програмата за до година, т.е. вече по месеци сме наредили някакви митъпи. Ако някой работи в компания, която иска да ни хостне, има интерес към това нещо, пак свържете се с мен, с Пас, с Владо, да го обсъдим това нещо, за да може да си направим програмата за цялата другата година, защото почват да се освобаждат компаниите, които искат да ни хостнат. И с това спирам, обещавам и давам думата на Райна да ни разкаже за Woman Who Grow.
Благодаря. Здравейте! Много се радвам да ви видя тук в пълна зала и искам да благодаря на Орлин, че ни покани да си партнираме заедно с комюнитите. За нас това е много важно. Общностите в София да работят заедно, за да имаме не само силно IT общество, но и да може да подпомагаме подрастващите да се развиват в IT сферата. Това е и една от нашите цели на Women Who Grow, да окуражаваме момичетата и жените да се включват в IT общността, но не само, да не се притесняват от технологиите, защото технологиите са навсякъде, не са само в IT индустрията и искаме да се обърнем към всички, към децата, в училищата, да окуражават всички да се докоснат до технологиите, да не се страхуват от тях и да открият съответния потенциал. Имаме си всичките социални мрежи, след събитието сме тук, ако имате въпроси, да се обърнете към нас. Окликс? Да.
Ще разцъкаш слайда. Добре, благодаря ти, Рени. Антон, ще се появиш ли, Антон? Hello! Следващите две теми ще са на английски. Заповядай.
Да. Здравейте на всички. Аз все още не говоря български, защото моята презентация ще бъде на английски. Hi everyone, I'm here to tell you about load balancing. So, my name is Anton Suslov. I'm the team lead for DevOps Cloud Infra team. Our responsibilities are the deployment framework for local and production deployments of Acronis Cyber Cloud. We maintain Kubernetes infrastructure for our component owners to speed up our development. And we are maintaining our internal cloud for our test environments. My personal value proposition is that I generally cause fewer production incidents than I help resolve. And I am committed to keeping it that way. So, load balancing. Why should you care about it? Well, first of all, if you have a self-managed Kubernetes cluster in production. Does anyone have? Okay, not that many people. Okay, I have more reasons. Maybe you enjoy long tirades about networking. Okay, or you want to have a deeper understanding of how load balancing actually works. Why should we care about that? Because generally, there are two DevOps schools of thought. First of them is it just works. You take a bunch of third-party components, you put them in your Kubernetes cluster, it works. But actually, sometimes it doesn't. Sometimes you get woken up at night because network packets are being dropped, nodes cannot connect to the Kubernetes API server, and something that is called SoftIRQ uses all your CPU time. Like, what the hell is all that? Well, let's figure out how we actually got here. So, how it all started. You are a simple man. You have a bare metal Kubernetes cluster. You want to route HTTP requests. You heard something about ingress, and you install ingress controller. You want load balancing. You Google. You find metal load balancing. Seems about right, correct? So you install it. Requests arrive. Responses go out. Life is generally good. But at some point, your request volume grows. Some of your nodes lose the connectivity to the API server. There is extra traffic across the node because you set up the load balancing incorrectly. There is your packet processing overhead is really high, and you have to do about something. Like, people start calling you. This is always unpleasant. So, about SoftIRQ. I keep mentioning that term, but let's understand what exactly it is. By default, in Linux, network packets are processed in kernel interrupt context. IRQ or SoftIRQ if we are talking about virtual machines. And by default, all packets are being processed on the first CPU core, CPU 0. That is a huge bottleneck if you have a lot of traffic. So, first thing you can do is to deploy IRQ balance to balance your IRQs. This job is really simple. Yeah, but still, we are talking about such balancing. Each network card still gets one core. So if you have ETH0, it is still pinned, but now to CPU 2, for instance, and ETH1 is pinned to CPU number 5, which is not great. Another mitigation you can do is to use something called receive packet steering to actually spread the packet processing across the cores. How does it work? The single core still receives the packets, but it puts them into the processing queue. So this queue is being consumed by multiple CPUs, and now the load is spread more or less evenly. You can configure it using sysnet, if name queues RX RPS CPUs, to set the specific CPU mask, and you reduce the bottleneck here. Now, about actually reducing the traffic, because if you have a lot of packets, what's the first thing to do? Do less packets. So, one big problem with Kubernetes by default is that your service objects generally do not provide any locality guarantees by default. So you can get a really unpleasant situation when the traffic comes in to node 1, and despite the ingress controller being on the node 1, it still goes to node 2 for processing. That's double network processing overhead for no real reason. That's like a very bad default. And the Kubernetes native solution to it is to use the external traffic policy field in the service objects. The default behavior is the one I mentioned, is cluster, but you can set it to local, and then the traffic will be routed only to the pods on the same node. So you remove crosstalk, and this vastly improves the picture. But still, you have a lot of issues, because as I mentioned, software queue is a big consumer of CPU time, and you get problems with it, because Kubernetes cannot split the balance and limit it using the C groups that it uses under the hood. So you get noisy nodes, and you get a noisy neighbor problem. For instance, you have 15 worker nodes, and you have only 2 external IP addresses. So actually, ingress is running only on those 2 nodes. And on those nodes, the software queue usage is high, and if you schedule any other workloads to it, they may start failing, even though the cluster seems to be balanced. But the CPU use will actually be high on these specific nodes, and it will cause a lot of performance degradations in production. So instead, what you should probably do, like you have only 2 public IPs. Why do you need more nodes than that? So move ingresses to separate nodes where you have metal LB and ingress and nothing else. This removes any instabilities related by relying on scheduling to make everything work just right, and instead everything just works right. And we are done here, right? Nope. As it turns out, you can get a situation where one of your nodes is doing a lot of work, processing a lot of traffic, while the other one is chilling. Why does it happen? You set them up in the same way. They each have 1 external IP address. They each have 1 instance of ingress controller. What is going wrong? Well, there is such a thing called DNS load balancing, where in your A record, if you have 2 IP addresses, the traffic might arrive to 1 IP address a lot more than to the second one. And you get this very not pretty picture. At this point in time, you start questioning your career choices, thinking about opening a bakery in Paris, and, well, you start wishing you were using cloud. Like, they do somehow this magic in the cloud. How do they do it? Like, what is the special sauce? When you hear load balancing in the cloud, it is something magical, something that just works. Well, let's figure it out. How does it work? I will not talk here about Google Cloud. I will not talk here about AWS. I will not talk about Azure, because they do use magic. They have their own software-defined networking, and I don't think anyone really wants to write their own software-defined networking for fun. There is no fun in networking. If we are talking about middle-of-the-road cloud providers that provide Kubernetes as a service, how do they usually do it? Well, actually, they do not assign public IP addresses to your nodes. Instead, they use node ports. So inside your managed Kubernetes cluster, there is usually a spy for the cloud called Cloud Controller Manager. And it talks to the cloud and says, OK, my cluster has these nodes. They have these IP addresses. There are these services that need to be exposed. And the cloud itself does its dirty deed. And then the traffic is routed to your pods using node ports. And if you are using external traffic policy local, in such a case, you also get a health check port. Kubelet listens on it. When health check requests come in, the kubelet responds if requests can be sent to this node or not. Can we actually replicate this? Actually, we can using HA proxy and KeepLFD, 2 very basic technologies. So here, in front of our ingress controllers, we put HA proxy instances with IP addresses managed by KeepLFD. We need some kind of a spy like Cloud Controller Manager, so we write a small Golang wrapper on top of proxy that will generate the configuration. Basically, it needs to check for the nodes and check for the load balancers. Then we implement health checks and assign public IPs using KeepLFD. And also, not to lose our client's IP addresses, we use the proxy protocol. And honestly, that's pretty much it. When we set up HA proxy like this, it behaves just like load balancers in the real cloud. So you can move your HA proxy to dedicated nodes. Then all CPU time can be spent on processing the incoming packets. And since HA proxy does nothing other than very dumb TCP proxying, basically CPU is free. You can use it strictly for processing incoming packets. And ingresses now get equal request load no matter what DNS strategy is picked here. And this load balancer scales from a tiny cluster to large production data centers. The only limits in how many HA proxies you can have are your imagination and your number of IP addresses. So basically, if you want to do load balancers like in cloud but on-premise, this is an approach you should consider. So what have we learned here? Load balancing is really not very hard. You can use off-the-shelf tools to actually balance the packets, and it is like you can do it in a weekend. And like processing network packets is not free and is something you should always be aware of. And the real load balancing is, of course, the friends we found along the way. Okay, that brings me to the end of my talk. If you have any questions. Yeah, sure.
Instead of HA proxy, can you use any other API gateway, like Ambassador or something like that?
You can use whatever you want. HA proxy is very simple to set up for this case, so you don't have to spend CPU on something other than just proxying TCP. It's mainly for performance reasons. You can do anything that can basically do health checks in this specific way. Oh my God, I accidentally closed it. How do I? Yeah. Basically, hold on. Basically, you need some proxy. How do I keep doing that? You basically need some proxy that can do health checks on a different port than the application port. And that's it. So HA proxy here is an example of why it is very simple.
Okay, thanks.
Check.
A lot of traffic. Well, in our case, we were hit by these soft IRQ issues at around 50,000 packets per second. Maybe when we installed IRQ balance, I think we got up to 100,000 packets per second, and it was already enough for us to get, like, these are real red pictures. These are real. I took them from our production. And this is never very fun. Our production is good. We fixed it. But yeah, we originally took it from there when we were investigating the issue.
Anyone else?
And this red picture. And I wanted to put some example configuration, but it's just slightly too long. So basically what I experimented with, I wrote an Ansible playbook that acted as an operator. It took stuff from Kubernetes, generated configuration based on it, and it set up HA proxy. Sadly, I do not have anything here to show as actual examples.
Okay, we can continue later.
Yeah, of course. Let me take out my laptop.
Yeah, my question is, by adding HA proxy in front of the ingress controllers, you're adding an extra hop.
Yeah.
Yeah. Can you eliminate the extra hop? Because, for example, HA proxy can be configured also as an ingress controller.
It can be configured as an ingress controller, but the thing here, the actual problem that we are originally trying to solve, is that when we put our external IPs on the nodes that process the traffic and process it in somewhat smart way, not just TCP proxying, you can get uneven load balancing. So for us, the thing that we want to do is to actually move the packet processing away from our ingress controllers to make it more even. Because if you have this picture isn't too bad. Like, our production is fine. But you get underutilization of one virtual machine and overutilization of another one. Basically, you either pay for the problem with your hardware, or you fix it via code, whatever is cheaper for you.
Okay, thanks.
Anyone else? No? Thank you, Anton.
Yeah, thank you.
And next one, we have Borislava. Welcome. Let me put that in for you.
Do I use this?
Mm-hmm. There you go. Floor is yours.
Okay. Hi, everyone. Today I'll show you a project which is part of CNCF, which is really intriguing to me, and I stumbled upon it as part of my work in VMware. So I'm excited to show it to you. It's quite niche. Probably many of you actually has anyone heard of it? Yeah, like 3 people, 4? Okay, good. So I guess you'll learn something new. So starting with a question, what makes Kubernetes a good platform if you consider it such? Is there any properties that you like about it? Extensibility, okay, that's quite in line. Anyone else? Great. Okay, I have exactly such a picture here. So what we have in Kubernetes is essentially a container orchestrator platform, but actually it's a lot more than that, because it's the whole architecture behind it which makes it so good. So it has this reconciliation mechanism which makes you input a declarative model of what you're trying to achieve and make the system constantly reconcile, react to changes in the environment, react to changes in your input, and basically achieve the desired state without you knowing how it does it. It's like magic. And the thing is, it does it initially for containers and for pods deployments, but it can also do it for any custom resource. And you can create your own types and create your own operators to reconcile the state. And this is really powerful. It's extensible. It's resilient. It is reactive to the environment in the sense that if something happens, it heals itself. So here we see the API of Kubernetes. It's using manifest files, and probably you have seen the pod manifest, which has the spec with the container image and so on. But what we really see in a more generic way is the whole idea of a manifest file, which gives you the desired state, gives you the type. It has natural versioning, and also any other information that you can put to your resources in order to process them, identify them, and so on. And here we see, don't mind the text, but it's a little bit of a more advanced example of what power Kubernetes has. So you can give it a Git repo with some files of the state that you want to achieve. And in the end is the state that you wanted to achieve. And in the middle is just Kubernetes doing its magic with operators, which can be, in this example, a chain of operators. So one notices changes in the Git repo, does something. Then the output of it is noticed by another. And then we get this whole chain of stuff, which in the end reconciles the state we want to achieve. And so this is actually, the previous example is a lot like what Crossplane does. It's a tool that does multi-cloud provisioning using the Kubernetes API. And here is a quote by them. They're saying that Kubernetes actually is a lot more than just a container orchestration platform. And the whole industry is increasingly trying to use all its advantages in order to base their own solutions on them, to reuse all the experience and years of development and community which went into the product. So we as developers, we like this platform. It has all these advantages. And I guess we have a solution. It fits into the model. And instead of reinventing Kubernetes, we actually want to use it. And is it that simple? Well, it turns out it's not really, because, well, Kubernetes wasn't meant for this use case. It has a lot of limitations, which are just by design, because what it was trying to do was to just be a container orchestration platform. So, for example, it doesn't really have good multi-tenancy. If you have a lot of users, you can't give them one cluster for them to share, because the only concept in Kubernetes which is used for multi-tenancy is namespaces, which is pretty weak isolation. And there are still all the cluster scoped resources which would be shared, and that's not a good experience. It has scalability, of course. You can horizontally scale Kubernetes cluster, but in the meaning that we have one cluster, it still has its limitations, like etcd and the API server. It hits some limits, and if we're a massive organization with a lot of clients, we can actually hit those object limits. And the scalability in Kubernetes is just to provision another cluster instead of doing one whole environment of clusters. And in the end, it's still a container platform. So if you try to use it for another thing, you would still have all the other stuff in Kubernetes, like the scheduler and the pods and all the components which you wouldn't really use. So this is exactly where KCP comes in, and it says, I want to be a platform just like Kubernetes, but I want to make it so a platform which people can use for their big SaaS systems, for example. So KCP is inherently multi-tenant. It has scalability, which we will see. and it just removes all the workload related stuff. So probably most of you have used Kubernetes for this. Well, KCP removes all those resources, but still remains Kubernetes. It's still completely compatible with all the ecosystem, all the tooling, all the client SDKs, and so on, but in a different way. It's for custom resources and APIs and not for the pods. So what are KCP's goals is to be a cloud-native control plane for your own APIs, but in a Kubernetes style. So you're not developing a REST API or a GraphQL API. You want your API to be Kubernetes style with the Kubernetes resource model. And KCP itself is not something that an end user would use. It's something that someone building a platform would use to base their platform upon, extend it with their own APIs, and provide it to the users. So it offers full isolation. It has the multi-tenancy, and all the tenants have their good isolation, not only the soft namespace one. It's of course extensible just like Kubernetes. And it has this interesting thing that it actually brings software as a service to the Kubernetes world, which we'll see. And like any platform, we expect it to be scalable, distributed, fault tolerant. It does that. So let's see how it does it. And first, let's start with the tenancy. So we start with the Kubernetes, and what would be our option if we want to give it to multiple users? The first one, as we mentioned, are the namespaces, which are pretty weak isolation. And namespaces were made, the whole Kubernetes was actually made to hand over to one user. It's not meant to be shared by multiple. So the namespaces by design weren't to have security between them. It was to have just that namespace isolation, to have the same names in multiple places and be used probably by multiple teams inside one organization. Then we say, okay, we want to have users and they want to use clusters. Let's give them separate clusters, but that's of course very expensive and hard to maintain. So we can do better. We can have clusters in virtual machines, therefore have more resource utilization. And that's definitely cheaper. It's a lot cheaper to spin up a new virtual machine. But just like Kubernetes, we can do even better and start with pods instead of VMs. So there's this other solution. It's called vClusters, quite famous, which actually does that. It provisions the Kube API server in pods inside one big host cluster, and etcd as well in namespaces in the host cluster, and reuse the host cluster's nodes for the actual runtime for the workloads. And there is also Hypershift, which does pretty much the same, but has its own node pools. So each tenant also has isolated compute. But KCP, of course, that was another bit cheaper. So it's cheaper to spin up pods than it was VMs. But KCP wants to do even better and has invented this logical cluster concept. So it goes beyond that and says, I even want to reuse one API server. I want to reuse the etcd data storage and have these clusters purely as a software-defined concept. So the logical, how they do that is by making, changing the API server itself and etcd in a way that they accommodate this multi-tenancy and having multiple clusters. And each cluster, even though it's in the same process, it uses the same storage, it has its own resources, its own RBAC, and so on. So they are completely isolated. And how this is done? Inside etcd and Kubernetes as a whole, each resource which we deploy in Kubernetes has is identified by this stuff. So what's its type, the group version and resource kind, and what is its name and an optional namespace. And then if we now want to support multiple clusters in the server, we also need to know which cluster the object is on. So we also include in the identifier the cluster name of the cluster it is on. So now in etcd and in all the URL paths in the API server, we also include the logical cluster name, and that's how logical clusters are implemented. And now we can use that concept of logical clusters to actually provide tenancy in Kubernetes. And this is done using workspaces. So workspaces are the unit of tenancy that one person or team gets. And to them, it appears fully like a Kubernetes cluster, and it's backed by a logical cluster on the backend. And we can see that workspaces in KCP are hierarchical, so we can model any organization structure which they want. And having this tree is quite cheap because getting one more workspace is a matter of milliseconds and just a very small bit of memory. It doesn't spin up any new processes. It doesn't spin up etcd. So creating a node here is creating a cluster, but it's extremely quick and cheap. And we can see each of the nodes have their own URLs, which include the path of the workspace. So from top to bottom. And yeah, basically this URL is just a Kubernetes cluster URL that you can now use in your kubeconfig, which you can connect to, query, have all your Go clients point to. And basically, when you get a workspace, because it's a cheap and a Kubernetes cluster, you can be your own admin in it. You can install any APIs which you want. You have full access, basically, because you're not affecting anyone else. So operations are easier inside such a setup. And because they have this hierarchical structure, they also decided to do this thing where they implement the kubectl plugin, which now can iterate through all those workspaces, like you're doing in a file directory with cd. So you start in root, and then you can get the workspaces, and you see its children, org A and org B, which shows that workspaces themselves are just Kubernetes objects, Kubernetes resources. And then you can say, go in org A, now you're in org A, and if you now do the same command with the workspaces, now you see team A and team B because you're in the context of another cluster. So this command essentially changes your kubeconfig. Okay, and those workspaces, again, to a person who is getting them, using them, seems exactly like a Kubernetes cluster. So it has all the airbag, all the APIs, you can use kubectl, as I said, authentication, and so on. So the only real difference is what are the resources inside it. So as I said, there are no pods in KCP because KCP isn't meant to orchestrate pods and likewise deployment, so on. It's made to have your custom API on it. So when you list all the resources in one workspace, you get a smaller list, which has some of the Kubernetes resources we know of, but they are just the general ones, which can be used by any API. So the config maps, the secrets, namespaces, service accounts for the RBAC, we have all that because we can just reuse it in our APIs. And we get additionally what we just saw, the workspace resource with which we can create and list all the workspaces in the current cluster. Okay, so we have our workspace, which is isolated to our single tenant. And now what can we do with it when it doesn't have any APIs? Well, we would like to add some APIs. And how are APIs added in a regular Kubernetes cluster? I guess someone here would know it. Yeah, CRDs. And that's one step, which we have to do. But there's a little bit more because we're in a multi-tenant world. And when you install CRD in the regular cluster, you define its schema, but also make it available to the whole cluster. And we don't want such a thing where all workspaces get crowded with all types, because when you're inside of your workspace, maybe you want to use just one of the types, and you want to bind only the types that you need. So we have the CRD, but it's mapped to an other KCP resource, which is an API resource schema, which contains all the information in the CRD, like what are its fields and so on, what are their types. And then you have the API export resource, which now, once you have the schema, it makes it available in KCP. So now you have this resource which the CRD defines. When you put it in an API export, now anyone in their own workspaces, if they want, can use it. And they can use it by doing an API binding from it. So let's see how this works in a picture. You have basically two personas in KCP because it's a platform. You have one team which are actually creating the APIs, creating the controllers that reconcile them, and another which is the consumer, which, for example, if we have DBs as the object which we export and we are a team provisioning databases, we can define how a database looks like in our API export by the service provider in his workspace. And now the API consumer has their own workspace and they have to create an API binding where in it they have to reference the API export which they want. And now this can be done in multiple workspaces. So the same API export can be referenced by many namespaces. And this is how it might look like in one organization where one team is working on something, for example, the SRE team provisioning databases. They export this functionality, this API, and another team A wants to create a database, so they want to use their API and they get it. And essentially, once they get it, in each of the workspaces, they can then create the resources which were exported. So the tricky thing here is, okay, we don't have the title, but the question was, oh yeah, there, how to reconcile objects in workspaces. So basically objects in regular Kubernetes clusters are reconciled with operators. So now in our workspace, we have an object, but it doesn't do anything. It just occupies memory, and someone has to act upon it. So do we have to also get the operator in our workspace in order to do something with it to actually provision the database? Well, no, because KCP has another idea about it, where there is one operator, which is multi-tenant, and it actually can see all the clusters and the DB objects inside them. So it can notice when you bind your workspace to the API, create your object, for example, a database object, and then they will do the work, create the database for you, but you won't have to do anything about it. So I guess you're wondering, well, are those operators secure then? When we have our workspace, another company has their own, and suddenly there's a controller which sees everything in all the workspaces. It is secured by having a specific view which the controller sees of the KCP state. So this is the virtual workspace, which sort of gets only the objects that the controller has to and needs to see from all the KCP workspaces and nothing more. And here is a graphic of this. So let's say we have these 3 workspaces with DB objects created in them. The virtual workspace will filter only the DB objects in the workspaces, and this is what the controller would see when it's reconciling. It wouldn't see the rest. It wouldn't see the certificates, and it would also see which workspace each resource is coming from, so they wouldn't make mistakes. And also, to facilitate this, KCP has done a fork of the controller runtime library, so you can develop your controllers in a KCP-aware way. So all your controllers would know what is a logical cluster and how to operate on objects in different clusters. And so how do they secure all this when we have the multi-tenancy? Well, as you can see, it's a pretty long list. Probably I haven't listed everything. There are a lot of mechanisms and levels of access. So you would need to have organizational access to get to the workspace. Then to get to any other workspace, you would have to have the access verb. This is another KCP extension of the Kubernetes RBAC. To have the access verb to get in a child workspace, then you have to have all the RBAC rights in the workspace itself, like your regular Kubernetes RBAC. To create new workspaces, you need rights to, if you're in a workspace and you want to consume an API, to create an API binding, you also need to have rights to that particular API, because maybe you aren't that privileged and can't create databases, so you wouldn't be able to do that. And also there are security on the service provider side of things. So the people who are doing the API export, maybe they need access to something more than just the regular resources. And for that, they have permission claims so that a controller can claim that they also want to see a config map in your workspace in order to work properly. And there are also other ways to enforce security, like identity hashes, to not have spoofing of types, but I guess that's a little bit more advanced. And here is what a permission claim works like. So when you're a service provider, you can say that apart from DBs, you also want to have access to config maps in the user workspace. This is in the spec of the API export. And then on the consumer side, in the binding you create to the export, you also have to accept this permission. So it's kind of like you download an app and it asks you to have access to your pictures. You actually have to give it access so that it can list them. And now these are basically the previous example was the controller has access to all your config maps, and probably you have other config maps which are completely unrelated to databases, and you don't want them to see a lot more than they want to. So you can also do a little bit more advanced filtering and actually tell it, I want to see exactly this config map and no one else. And also give it references to resources from other exports with this identity hash which we saw. So that was the multi-tenancy, that was adding APIs and reconciling APIs, but we still have all the scalability limits of a single Kubernetes cluster, and we said that that's not enough for us. So KCP adds the concept of sharding, which horizontally scales your KCP instance, but in a smarter way using shards. So how is this done? You can have multiple shards, which are kind of separate KCP instances. They have their API server and etcd this time apart. And each shard hosts some subset of the workspaces, but presumably it can't host all, so the other shard takes the rest. And so on. You can have more than two. So each workspace gets assigned, when it's created, it gets assigned to one of these shards, and all its content is there in one etcd, and all the requests to that workspace go through its API server. And because these aren't isolated, they actually act as one KCP instance. In order to facilitate all this, there is a distributed cache server which hosts some shared objects which are needed in order for it to work like one whole. And now that we actually have multiple workspaces, how can they be reconciled by controllers? Well, each controller, basically like we saw before, points to one virtual workspace, which gives you that computed view of only the resources in workspaces which you want to see. So we can take that approach. And because there's a virtual workspace per shard, so there are as many virtual workspaces as shards, and you can have one controller facilitating just one of the URLs and basically reconciling only the objects inside the workspaces in the shard. So that's how that would work. And also there is more control which you can get to add kind of regional controllers which don't operate just on one shard, but on more, on some filtering rule. So this specific setup has one controller per region and operates on all the workspaces inside those regions. This is done by partitioning. And basically it operates on multiple virtual workspaces, probably in some Go routines. And this is a sneak peek of how it does it. Basically, KCP has an API resource for this, which gives you the endpoints you need to connect to from your controller. So that was all the technical details. But I guess the big question is, why would we use KCP? What are its use cases? And it has quite a lot of use cases because it's essentially a platform and you can use it for whatever you decide, as long as it fits into the Kubernetes architecture model. So something you can do it is to have your internal developer platforms on it, to expose services from one workspace and consume it by all others. You can have infrastructure as a service platforms, just like Crossplane to do multi-cloud with Kubernetes resources for each cloud resource, and then it going to the cloud in the operator. Some people actually say that you can use it for IoT and Edge. I'd be interested to see that. There was a talk about using it in fridges, so I don't know how that works. And transparent multi-cluster is actually a big use case, which was part of the KCP project until last year, and it's something which we actually use, but they removed it, so now we maintain a fork of it. And it's used to have one workload in KCP and actual physical clusters outside of it. So the KCP controls the physical clusters and schedules workloads on them. And yeah, like any other tool, it also has its shortcomings. So why would you not use it? Maybe because it's not very mature yet. It's a CNCF sandbox project still since last year. And all the rest are just architectural decisions, like Kubernetes as a whole is not meant to store large amounts of data. etcd is not meant for big data like AI and so on. And it's by nature, the whole reconciliation mechanism is eventually consistent. So if you need to have transaction management, if you need to have any synchronicity guarantees, it wouldn't be a good use case to have a Kubernetes-style API at all. So that was it. And if you have any questions? Thanks.
Yeah, thank you for the interesting presentation. I have a question. How do you deploy KCP? Is it like separate instances, or it can be an existing Kubernetes cluster? Does it interoperate with the standard control plane of Kubernetes?
No, it's actually a separate project. It builds upon Kubernetes. It's a fork of it, but you start it on its own. So you can't start a Kubernetes and then take it in, because it modifies the whole API server. So it uses a different API server essentially to support all this stuff.
Yeah, so I'm here. Thank you for the presentation. I was wondering, in the use case in which you do not mind a bit of pause in reconciliation, can you, instead of sharding, make use of some kind of backup
and just have one instance, but then if there is a fail on the system, just restore it from backup.
Yeah, I guess you can do that. I'm not sure if there's a mechanism ingrained to KCP or you would have to have custom logic in it. The point with shards is that if the one KCP instance is not enough for all the workspace, if you have a lot of clients, they all have a lot of clusters, you would actually use the additional instances not for fault tolerance, but to store all the new data. That's, yeah. But you can also, I think you can do fault tolerance too.
Yeah, I have a question. So KCP itself doesn't run. Oh, sorry. No. Oh, I'm very sorry. Yeah. So KCP doesn't run any workloads, but where do operators run then?
Operators run as separate processes, so they aren't in the KCP kind of. They run on a Kubernetes cluster on a regular one as pods, which connect to the URLs which you saw, which are the KCP exposed ones.
Okay, I see. Thank you.
How do you handle persistent storage with KCP?
You can have persistent storage in etcd, basically, because it uses etcd. And I guess also any operator can talk to whatever database they want on the backend. So if you have a Postgres, the operator can just write to Postgres itself. Or you can have an etcd shim. That's actually something we do. So we actually have a Postgres instead of an etcd on the backend using Kine.
Okay, thank you.
Anyone else? Ooh.
Thank you for your talk. Since you need access to the etcd, I guess they don't plan to integrate it with a managed cloud, with a managed Kubernetes. You have to self-host it.
I guess I'm not sure about that, to be honest. I think you can run it on. You definitely can run it on a cloud. But if you're talking like EKS,
exactly.
Yeah, no, that isn't supported. Yeah. But they
Thank
do
you.
have talks to actually have that part of the regular case. It's just not something done yet. Yes?
Thank you for the interesting presentation. I have a couple of questions. First one is, do you know if KCP supports multiple operator versions in some manner, like exports or something like that?
Yeah, it does, because in each workspace, you can create your own exports and schemas. So you can have two separate workspaces which define the same resources in terms of kind resource version. Actually, that thing with the identity hashes is exactly for that. Because if you have two workspaces having the same resources defined, by this hash, they uniquely identify which is the export, so which controller should operate on the resources and so on.
Awesome, thanks. And the other one is, are you aware if the isolation prevents stupid things like trying to connect to the IP of another workload somehow from the workload that you're not on?
Well, by workload, do you mean the controller? Or
sorry, workspace. So for example, do you prevent somehow access using more Linux primitive ways between workspaces?
It uses kind of Kubernetes RBAC as far as I understand. So all these verbs are used in order for you. You have to authenticate to the KCP like a regular user. And then if you have rights, you can access the resources on that cluster or not, but maybe lower level, someone could break it, I don't know. Yeah.
Hi, thank you. So the multi-tenancy isolation is perfect. Why not pods?
You can actually have pods. It's just that KCP wants to provide like a empty platform where then you can reintroduce pods if you want, and all the operators acting on pods. Or you can also connect KCP, like I said that we do, to a regular physical cluster and can actually talk to that physical cluster, schedule workloads on it, and so on. But it's just like for platforms which don't actually do pod management. If they do pod management, they would have to define the API, get it inside, and so on. Did I answer? Okay.
Anyone else? I have one. You partially answered it, that the project is not mature enough. But can you compare it like maturity with vCluster or Kamaji? And if you're aware, no, okay.
No, to be honest, I think it's pretty mature, but it's not very well adopted. It still is yet to have like big adopters. I think we're the first one, kind of, and maybe that's the reason. And not also, it's in active development. As I said, they were having some components last year which we used, and then they removed them. So yeah, it's kind of unstable in that sense.
Is there any big company behind the project?
I think it was
or any company,
Red Hat which
Red Hat?
started it. Not sure. This has to be checked, but yes.
Thank you. Anyone else? Any more questions? If not, thank you. Should I switch to English or not? I don't know. Two things. 3 minutes until the food is served, so I have to tell a joke. No, there's stickers over there. Please be mindful, and they're in a box. So, and they're in little envelopes. So please put it back when you take your sticker out. Otherwise, it will be super messy. Once again, next time, 21st of November, in SiteGround. Thank you. So, which is, I don't know, that direction. Anyway, thank you very much. Thank you for the speakers today, and see you next time.